We are given the square root function f of x equals the square root of the quantity 4x plus 16, and we're first asked to determine the x-intercept. The x-intercept is the point where the graph intersects the x-axis. Every point on the x-axis has a y value or function value of 0, which indicates to find the x-intercept, we set f of x equal to 0 and solve for x. This gives us the equation 0 equals the square root of the quantity 4x plus 16. To undo the square root and solve for x, we now square both sides of the equation. This gives us 0 equals 4x plus 16. For the next step, we subtract 16 on both sides, which gives us negative 16 equals 4x. Then divide both sides by 4. Simplifying, we have x equals negative 4. But again, this is a point on the x-axis. The ordered pair is negative 4, 0. Let's go ahead and plot this on the coordinate plane below. And now we want to find the y-intercept, which is where the graph intersects the y-axis. Every point on the y-axis has an x value of 0, which indicates to find the y-intercept, we set x equal to 0 and solve for y, or determine f of 0. F of 0 is equal to the square root of the quantity 4 times 0 plus 16, which equals the square root of 16, which is 4. Again, the y-intercept is a point on the coordinate plane. The ordered pair is 0, 4. Let's also plot this point on the coordinate plane. Just from these 2 points, we can make a nice graph of the square root function. For the next part, they want us to find the domain, which is a set of all possible inputs. In order for the function values to be real, the radicand, or in this case the quantity 4x plus 16, must be non-negative, meaning greater than or equal to 0. So to find the domain, we need to solve the inequality 4x plus 16 greater than or equal to 0. First step, subtract 16 on both sides. Next, divide both sides by 4. Simplifying, we have x greater than or equal to negative 4. We want to express this using interval notation, which would be the interval from negative 4 to infinity. The interval is closed on negative 4 or includes negative 4. We use a square bracket to the left of negative 4 and a parenthesis to the right of infinity. And now we're asked to graph the function, which we can because we know the function passes through these 2 points. Before we do this, though, let's describe how the given function f of x is a transformation of the basic square root function graphed here on the right. To do this, we need to write the function in the form shown here. Notice we need to factor under the square root, which means we need to factor 4x plus 16. The given function is equivalent to f of x equals the square root of the product of 4 and the quantity x plus 4. Notice 4 times the quantity x plus 4 is a factored form of 4x plus 16. In this form, notice we have b equals 4 and c equals negative 4 because x minus negative 4 simplifies to x plus 4. b equals 4 indicates a horizontal compression by a factor of 1 divided by b, or by a factor of 1/4. C equals negative 4 indicates a shift left 4 units. So just to find one more point on the graph of f of x, let's select one point on the graph of the basic square root function and perform these 2 transformations. For example, let's use the point 4, 2. Starting with the point 4, 2 on the basic square root function, to perform a horizontal compression by a factor of 1/4, we multiply the x value of 4 by 1/4. The corresponding point is 1/4 times 4, 2, which is 1, 2. And then to shift this point left 4 units, we now subtract 4 from the x value. 1 minus 4 is negative 3, resulting in the ordered pair negative 3, 2. This point is another point that's on the graph of f of x. Let's go ahead and plot this point, negative 3, 2. And now let's go ahead and graph f of x. Notice the graph does verify the domain which is x greater than or equal to -4. And also notice the range would be y greater than or equal to 0. I hope you found this helpful.